My screen.
Looks good to me.
Cool. Yeah. Okay. So it's probably quite weird to hear a geographer like me talking about web data, internet, and all of these things. But I guess this is my weird research interest, as Kate has indicated. My research has been focusing on understanding the relationship between digital and material, digital communication, digital technologies, digital economy, and the materiality of cities, of real places, of regions and urban systems. And within this broader framework, we're presenting today, two different strands of research. I will start by focusing on a project we have been working on, which tries to understand and mostly predict regional trade flows using data from the web. And then Giulia, the second part of the presentation, will focus on the most interesting part of the hour. She will be talking about SIC codes and how we can use web data to understand, industrial classifications at a more detailed level than standard industrial classifications. And Giulia will talk, will say all about this later on. So let me start by focusing on the more geographical, if you prefer, part of the talk. I'll quickly introduce the topic. I'll talk about the data we're using, and I'll move on to our empirical strategy. I will skip the descriptive statistics, and hopefully I will have enough time to talk to guide you through our results. You can find these slides on my website in case you're interested to go through them again. And let me start by introducing the main topic of our work. We're focusing on regional trade flows. In general, bilateral trade, so trade between countries, is a complex phenomenon. We know that, there is a lot of research, at the macro country level trade, and we know how difficult it is to, understand and model trade. When we go to a lower level, to more spatially detailed level, the level of regions, because regions also trade, with other regions, this complexity actually increases. Regions are more specialized and also more open to trade than countries. They are open to external trade, dependencies. They depend a lot to other regions within their own country, or with other or with regions with other countries. And importantly, their specializations vary a lot in terms of, what type of products they produce and trade with other regions, what type of imports or exports they do. However, knowing and predicting trades between regions is very important for, regional economists, regional planners, regional authorities. It's very important because it helps us understand more about regional economic performance, help us understand how exposed regions are to external economic shocks, and at the end of the day, help us design place-based development policies. However, there is a big caveat here. There is hardly any interregional trade data. So although there is a lot of data about country-to-country trade, there is very little data about region-to-region trade. At the European level, we have some data about interregional trade, and these data are the outcome of spatially disaggregated country-level input-output tables. So, although there is some data at the European level, these data were produced through a very costly and difficult, exercise. So what we're trying to do here is to utilize the digital traces that trade leaves behind. And when I talk about digital traces, I refer to web data in order to model and predict region to region trade flows within the UK. We are doing this actually by utilizing hyperlinks between commercial websites. We use some standard machine learning techniques to make predictions of unseen trade flows in the UK. And we also were also able to further disaggregate our results. And I'll explain to you what I mean. Let me just briefly, refer to previous literature. By no means, we're not the first ones utilizing web data, and more specifically, hyperlinks between websites in order to understand, spatial relationships across space between places. Okay, and I list here, quite a few studies which utilize to a different capacity such data, but I don't think I have the time to go into detail about this. What's more important is to illustrate that other studies used web data in order to understand better business practices. So why do we expect, why is it useful to use business website data to understand, business practices? One might say that, businesses, are not going to reveal all of their strategies on their websites. However, this might be true also for surveys. And you gotta bear in mind that, surveys has been traditionally the main source for business data. On top of that, business websites have very specific functionalities. They are there in order to help, businesses, spread information and establish a public image. So in essence, companies have incentives to present, themselves, present what they do, on their business websites. And this is what we are utilizing here for our research. Previous research has also utilized hyperlinks between business websites to extract useful business information, also about trade or innovation and innovative relationships. So there is a little bit of research into this domain. Let me try now to explain what we do. I mentioned that we use web data. I wasn't very accurate. We are using archived web data, so not live web data, but web data that has been archived. More specifically, we use data from the Internet Archive. The Internet Archive is the largest archive of web pages in the world. It started in 1996, and since then, it crawls the web and creates copies of the websites it goes through. The main aim of the Internet Archive, just like other web archives, is to preserve all of these web data that otherwise would have been lost. Importantly, by doing this, by archiving websites, we also obtain information about the time of the archival. So in essence, we have a timestamp of the data collection process. So you can access these data through the Internet Archive's graphic user interface. So this is the well-known Wayback Machine, and you can go, to the website they have, and try to find archived versions of different websites. And this is, an example of Bloomberg, which have been archived, every day in 2015, multiple times per day. And this is how Bloomberg looked on a specific day in 2015. Great. We're very, very lucky that we're also able to access these data programmatically. So we have been working with the British Library, and the British Library has done something very clever. They created this data set, they call it the JISC UK web domain dataset, which includes all the archived .uk web pages, which are included in the Internet Archive between 1996 and 2010. We've used this data before in other studies, and it's a very exciting data set for us, although very challenging to work with. So we're using two data sets of this, broader data set they have created. The first one is what they refer to as the GeoIndex. This is our means to geolocate web pages and websites, and I will explain later on the distinction between these two. So we start by having something like 500 million of lines that look like this. Okay, so what does this line says to us? It says that this specific web page was archived on the 9th of May of 2008, and importantly, this the HTML document of this archived web page included this string of text, which looks like a UK postcode. So we're able to geolocate these web pages using mentions to UK postcodes within the text. So we have spatial information, and we also have the temporal information based on the timestamp. So this is the first data set we use. The second data set we use, again from the same source, refers to hyperlinks. So in essence, we have lines, data that look like this, and we know that there are 3 hyperlinks which start from this website and end to this website. So what we do, briefly speaking, is to match these two data sets and create a spatial network, if you prefer, of hyperlinks between geolocated websites. This is the main source of data we use, and then we utilize these data in order to build models that enable us to predict trade. So if this hyperlinks feature is the hyperlinks that we know that exist between places I and J during time t, we also utilize some other mainstream predictors that we know from the literature that are very well associated with the national trade, such as the distance between these two places, the population density and the volume of employment in these places. And then we use these features in order to predict trade between places I and J, in here T, as this illustrates. What is this trade data? This is the only available interregional trade data we have in Europe that I mentioned in the very beginning. We utilize some standard machine learning algorithms in order to train and utilize our models, and these are random trees. I'm not going to justify to this audience why we're using random trees. What is more important is to say a few more things about our modeling strategy, which is based on the idea of rolling forecasting. So what we're doing here is to train our models using data from years t and t+1 in order to increase the size of the training set of the training data set. Introduce a tenfold cross-validation, and then use this trained model to predict unseen data from years t+2. So in essence, we are using, this model to make out of sample predictions, and we also avoid any data leakage. We're not using, present data to predict past data. This is the main, modeling strategy we're adopting here. We utilize standard predictive performance statistics. There is a lot of data cleaning that went, under the hood. The only thing that I would like to mention here is that we start our analysis from archived web pages, but we try to we aggregate these web pages to websites. As you see, in this example, these two archived web pages we can infer that are part of this, website. And by doing that, we end up having a quite broad distribution of websites regarding the number of postcodes that are included in their HTML archived text. At the left-hand side of the distribution, we have websites with one unique postcode. And an example is, this website, which has, it's called Geeks Nerds. They offered IT services in Shoreditch. They have one unique postcode indicating that this business, focuses, has one trade address. At the other end of the spectrum, we have websites with multiple or even thousands postcodes. And this would not be something strange to the older people in the room, as it represents directory types of websites where that was the pre-Google era, which was the main way to, this yellow type of web pages was the main way to navigate through the web. And we make distinctions about the number of unique, or we filter out data based on the number of unique postcodes that these websites include. Enough with the data. Let me jump to our baseline results. We trained our data, our models, using data from years t and t+1, and then we apply our models to year t+2, to unseen data from year t+2. And the results are quite good, actually. So for most of the years, we receive, we achieve an R-squared above 0.96. So this 2002 means that we used data from years 2000 and 2001. We trained our model using these data, and then we applied this model to unseen data from 2002, and we achieved these metrics, as you can see on the screen. Same thing with the graph. We were able to decompose our data in terms of sectors, because we also had information about trades for different, sectors, and we identified sectors for which we're able to make better predictions, and equally sectors for which we were not able to make such good predictions. And hotels and restaurants was one of these sectors that we cannot easily predict because of the peculiarities of how this sector, trades by focusing on very local trade interdependencies. We were able to also test different specifications, which highlighted, of course, the important role that distance plays in predicting trade. We did some robustness checks by using, different data sets, different size of training data, but the results, are fairly the same. And the last thing that we did, and this is what I'm going to close to, we utilized the spatial granularity of our data, and we used the trained models in order to map interregional trade flows at a much lower geographical level. So here we have, we were able to map flows between local authorities in the UK, for which level we have no data whatsoever. So to finalize, we think that we're able to use interregional, we're able to predict interregional trade, which is very difficult to capture in general, by utilizing current standard machine learning algorithms, and most importantly open data from the web. Within our research framework, we're able to do, to achieve high accuracy prediction of interregional trade. We're able to spatially disaggregate and sectorally disaggregate our results. And we believe that this disaggregation can help, local authorities obtain a clearer picture of the trade dependencies of their own territories. And I think I'm gonna stop here. You don't want to see the references. Kate, shall we take questions at the end, or now, whatever you guys think?
I'm looking. I'll just look quickly around the room. If you want to take your talk off the screen, I'll have a look at and see if anybody would like to answer questions now, or if you'd like a few minutes and we can come back to questions at the end. I'm not seeing any hands raised right now, so I think people need some time to absorb. So let's move on to Giulia with a second presentation, and then we can come back to some questions at the end. Thank you so much, Emmanouil. That was really fascinating. Okay, Giulia, over to you.
Thank you. Thank you, Emmanouil. Thank you, everyone. Hello, I'm Giulia Occhini. I am a PhD student at the University of Bristol, founded and based at the Alan Turing Institute. And today I'm going to talk a little bit about NLP, websites, and the industrial classification problem. Apologies to Emmanouil, my supervisor, who's heard this story at least 4,000 times. As this is a data seminar, we're gonna mainly discuss data, and I'm gonna start with introducing the industrial classification problem, why should we care about it, and previous work. I'm then going to talk a little bit about website and web page classification problem in a bit of a different light than the one that Emmanouil just explained. I'm then going to discuss methods in contextualized language modeling and weak supervision, and I'm then going to conclude with some final remarks. But first, what is industrial classification? Industrial classification is the main way in which national and international statistical agencies define the taxonomy of existing economic activities. In the UK, industrial classification is expressed through standard industrial classification codes or SIC codes. These codes have been deemed to be too broad to describe newly emerging industries, and they're mostly oriented towards retail type of activities. Indeed, this is mostly because the last time that these codes were updated was in 2007. Codes are obtained by the ONS through annual surveys, so companies are compelled by law to compile these annual business surveys, which are slow and costly, and often entrepreneurs do not know how to classify themselves, resorting to the not elsewhere classified code. So why should we care? You could wonder, okay, this is a bit of a boring problem, but it is really not a boring problem, because how do we gain insight into a country's innovative endeavors with an obsolete taxonomy of economic activities? You could say that we could do this through patents, as generally patents are seen as what talks most about innovation in a country, but not all business activities translate into a patent. Also, we need to use industrial classification to understand the demographic categories that engage with innovative economic activities, as well as to understand those famous spatial signatures that Emmanouil was talking about of economic activity. So if you think that the way that we still look at the economy is a pre-internet way, you can imagine that this is a bit confusing. There is not a lot of previous work in terms of industrial classification. The main work that has been done in the UK is this paper by Nathan Rosso called Mapping Digital Business with Big Data, Some Early Findings from the UK. To be clear, these things that I'm talking about in this meeting are applicable to all the world, not just about the UK, but because we are in the UK, we're talking about the UK. This work is a very good work, and it utilizes commercial website texts, discovering that most companies that categorize themselves as not elsewhere classified are in innovative ICT sectors. They indeed quantitatively demonstrated that SIC codes are not just inadequate on paper, but they are actually inadequate to describe technological advances. There are some problems with this research. So first of all, the problem is identified. So now we know that SIC codes are not granular enough to describe the economy, but the problem is not solved in this paper. Also, the authors, while they use textual data extracted from websites, they do no specific modeling, and they just use word counts. They also just use bag of words approaches, which at this point in time are a bit obsolete in NLP. And they also use a data set provided by a third-party company without providing any external validation. So the main question of this presentation is there a way that more advanced language modeling and website text could help us understand industrial classification and solve the industrial classification problem? So the first step that we did towards solving this problem was finding industrial websites. So our main idea was to find freely available industrial websites and not having to rely into proprietary data sets. The first place where you can search for websites could be Companies House. Companies House is the place where the census of company is uploaded every year in the UK. And in Companies House, the problem is that websites are just not there. So what you can do is downloading in bulk some Excel spreadsheets that have got information such as a company's name, a postcode, the registration number, and the SIC code. So my idea was, okay, what if I can find a way to merge data of Companies House with websites myself? What we tried to do was scraping all landing pages from all.co.uk websites that we could find in the common crawl. The common crawl is a bit like the web archive that Emmanouil talked about, but it has a slightly difference that it collects more data also from other countries. The amount of data that we scraped was 5 million, but don't worry, this didn't take a lot of time because we did it in parallel and we did it on a computing cluster. We then devised a little algorithm, which is not very complicated, that would put all the data from companies on a data frame, including company's name, postcodes, and registration number, and have a list of all the website text that we scraped from Common Crawl. For each row in this data frame, we would then see if the name of the company was in the website text, then we would append an output, same thing with postcodes, and same things with registration numbers. Unfortunately, this didn't work because generally the way that companies call themselves on the website is quite different from the way that they call themselves in the registration. So if a company, for instance, was called Giulia Ltd, they probably wouldn't call themselves Giulia Ltd in their website. So I failed at attempting to do this myself. And in the end, I had to rely on a proprietary data set. I relied on FAME, which is basically a copy of the Companies House data set with the advantage of reporting websites. FAME is basically very much famous in the finance and business economic research. And it is accessible through Bristol, so I didn't have to pay anyone to access this data, which is always good. And I also managed to validate this data. And I validated against the ONS business census. So what you can see on the y-axis is the normalized frequency of companies, and on the x-axis, you can see the distribution of the companies per SIC code. And you can see that between FAME and the ONS business census, they kind of look the same, luckily. Sorry. I'm now turning a bit more into the intrinsic problems relative to website classification. So NLP tasks at big computational linguistics conferences are generally carried out on relatively clean, well-structured, well-punctuated text. The problem is that website text is often actually trash. There is no punctuation, sentences are very short, sometimes they're just keywords, and the style can change from sentence to sentence. And there are a whole lot of HTML tags. In the context of patents, which have been used in the past to classify economic activities, but as I said before, they do not reflect the whole economic panorama of a country, the help of multimodal machine learning has been suggested, which means analyzing both the text of the patent and the figures in the patent and unifying the inference. So for instance, here you can see a figure extracted from a patent of a famous pair of sneakers, and whichever CNN you would use in an image like this would infer quite easily that this patent is talking about a pair of sneakers. Unfortunately, however, images in commercial websites are just evocative and never literal. So for instance, here you can see the first page of Meta, which was called Facebook until some months ago, and the image that this website presents does not have a lot to do with the actual entrepreneurial endeavor of the company, and probably would not help us to classify this industry. Another question that we have, and that is intrinsic to website classification, is how much website is enough website? Websites generally are a network that expand, and it can expand to become insanely big. So how do you treat hyperlinks? Do you scrape just the landing page of a website, or do you scrape also the text within hyperlinks? And within those hyperlinks, do you continue going through the other hyperlinks that they direct to? Also, how do you treat pages in different languages and pages in different styles, which happens a lot of times? Here you can see a representation of the network that website may make, where in the center is a target page, so the landing page, and on the side are those pages that are in connected hyperlinks. This image is not from me, and I should have cited it better, apologies. So to summarize what I've said till now, current industrial classification codes are not representative and are outdated. NLP techniques are promising from the tasks, but need to be optimized for the difficulties of text scrape from websites. Unfortunately, it was not possible to create our own open access data set of websites and company, but we're hopeful that this could change. And you could ask me, but have you tried scraping companies' information from LinkedIn? Because on LinkedIn and on other websites like Data Crunch or something like that, it is possible to find a lot of information about companies. The problem is that this is legal and I would probably get sued. And that's why I didn't do it. So I'm now going to move towards the methodology part of the presentation, where I will talk about contextualized weak supervision and manual validation. So I'm not going to go into a lot of detail about the methodology because it would take way more than 10 minutes, but I'm going to explain a bit the paper that we took our methodology from. This paper is from Mekal and Shang from 2020 and is called Contextualized Weak Supervision. And if you're interested, I would strongly suggest to have a look at it because it's very well written and everyone can understand it, I feel. So the method is based on the idea that we could define our own taxonomy of industries and assign them some indicative keywords. We could then use our own taxonomy of industries as a training data set for in the future fine-tune a big language model and do some transfer learning and use this data to classify websites of industries that we've never seen. So using a general weak supervision framework, we could generate pseudo labels in a context-free manner. For instance, a label could be the argmax of all the summary of term frequencies of a keyword within a document for all the keywords within all the labels that we defined in the taxonomy. However, such pseudo label would be, again, bag of word based, as the paper that we criticized at the beginning of the talk, and they would not capture the contextual property of language. So they wouldn't entail a lot of improvement. Also, a lot, since it's again a bag of words approach based on term frequency, a lot of documents could be wrongly associated to a label, and we wouldn't have a very high level of accuracy. And this is where contextualization comes into play. So we add contextualized language model to the mix, and we disambiguate representation of word occurrences that have a different interpretation. So for instance, if I have an example where I explain the concept of contextualization in a very simple way. So if you consider these sentences, my phone fell into the well, and well, I just lost my phone. In these two cases, the word is the same, but the meaning is very different. And generally in NLP, if you code these words, they would have the same embedding. Through contextualization, you can give different embeddings to these words and have them have a different interpretation. So we create a contextualized corpus of all website extracted documents, and we use this contextualized corpus to train a classify and disambiguate our seed words and expand them in an iterative manner. In the previous slide, I just tackled a bit the problem of the quality of text that we have. So we do not have text that is very well structured. Using contextualization can help us to make this text more interpretable. But what about the quantity of text that we need to use for industrial classification? Well, to understand what's the optimal quantity of text that we need for this task, we did an ablation study. And an ablation study consists in comparing the results between two different corpora of scraped websites. In the first case, the corpus is comprised by all the landing web page of the website that we scraped. And in the second case, the corpus is comprised by all the text extracted from all the hyperlink contained in the landing page within the website. So if my starting website was www.giulia.com, then I would go in the links within that. So for an example, www.giulia.com.about. But I wouldn't go in websites such as like Twitter/Giulia or Facebook/Giulia. Adding those websites would add a lot of layers of entropy and a lot more computation. So we do not think that it is a good idea. So we're hopeful that creating a training data set of granularly classified industrial websites can provide us with the right tool to fine-tune a big transfer learning model and be able to classify never before seen industries without relying on SIC codes. While it would be optimal to trust the weak labeling model blindly, because we know that in the paper they obtain very high level of accuracy, this would be a bad idea, because in the paper, again, that was published at a big computational linguistics conference, the data set that they test the model is quite optimal. So they test it on like New York Times news. So in our case, since we didn't have a training data set ourselves, we had to get our hands dirty and manually validate a lot of the websites. So we took a sample of around 300 websites and manually validated them. The F1 score that we obtained for just landing pages is 87%, which is quite satisfying. And I still have to manually calculate the F1 score for websites where I did not just scrape the landing page, but also hyperlinks within the page. So to summarize, we propose using a contextualized weak supervision algorithm to create a granular training data set for industrial classification tasks, relying on website extracted document. And the process involves some extent of manual validation. And while people generally do not talk a lot about manual validation in machine learning, we think that it's worth it. Also, some final personal considerations. My PhD, 99 of it is spent in creating data sets and cleaning data, but I think that it's a nice way to spend the PhD, and I'm quite proud of it. Also, why am I spending so much time on LaTeX presentation? I don't know. It literally takes me days. If you have better ideas, please let me know. And yeah, if you have any questions, feel free to shoot. Thank you.
Thank you so much, Giulia. Thank you. Yeah, so what we try and do is if people feel comfortable showing their faces for a bit so that our speakers can see some people in the room, and then we can get some questions going. So I've got one for you, Emmanouil, just to kind of kick off. You've got a really wide time frame for that big data set, and I was just wondering whether does the web behavior, if you like, of companies change through time, and does that have an impact on what use you can put the information extracted from those data sets for thinking about your trade flows, your trade connections?
Well, that is a very good question. The web is not constant, but the web is not also designed for researchers to take snapshots of it, right? So we exogenously impose this temporal dimension, right? So the temporal dimension here represents the archival time, not the web page creation time, which is not observable. Okay. Nevertheless, we've done some tests in order to see how this, in order to understand the behavior of the web scraper over time. And if we observe your website, or if your website was archived in 2005 and in 2006, chances are that your website was also archived in 2005. So there are no gaps. Once your website enters, you know, the archived data set, keeps to be archived again and have a presence over time. We saw some, we observed some time effects in terms of the accuracy of our predictions, which are not necessarily endogenous to the data. So when we trade for the trained models during the financial crisis, our prediction drops, right? So there are some exogenous shocks here. There are also some data collection, well, I wouldn't call it issues, but irregularities, right? For example, 2004, we had a lot of web farming type of things, or hyperlink farming. And this also is reflected to a certain extent on our prediction scores.
Okay, thank you. It's really helpful. Lawrence says, oh, you don't have a raise your hand icon. That's strange. Anyway, I will ask your question, Lawrence. How do I indicate? Oh, sorry. So just put your hand up. Show your face. Where are you? Or ask your question in the chat.
Okay. I'm now unmuted. Can you hear me?
Yes, we can. Okay.
Basically, could I say thank you for two very interesting papers? Two important questions. One is, how do you get hold of printed copies of those, or online copies, so that we can peruse them at our leisure? And secondly, a question I think for Giulia more than others, has anybody tried a combination of QDA minor and WordStat to try to analyze these data? They look to me at first sight, I've not used them in anger, but at first sight, they look to me eminently suitable for what you're doing. Have you tried it? End of question.
Emmanouil, I don't know if you have a paper copy of this paper.
I can send it. Yeah, I can circulate it.
What I could say just quickly on that, we have recorded these talks, so they will be going up on our website. So you can always revisit them that way as well.
Thank you.
And yeah, my paper is still baking, so it will be available in not a lot of months, hopefully. But I am not sure that I know what WordStat is. Generally, I do everything in Python or R, but I'm not sure if I'm understanding if this is a tool that is generally used for language modeling.
Yes, it is, and they do topic modeling and all sorts of things.
Ah, okay,
There's
okay.
a company called Provalis, Provalis in Canada.
Okay, okay. I generally write my own scripts to avoid having to pay someone else. But yeah, they're available on my GitHub.
So do I. I would add, but this is it saves a lot of time.
Yeah, yeah.
Okay, great. Any other questions? Dan.
So since we've only got the geeky folks remaining, could you spend a little bit more time on the technical, like how does one embed these words? Is it something like the word to vec? And if so, well, could you tell us, what information it's using?
Yeah, it's something like word2vec, exactly. The corpus, the full corpus of websites is embedded through a BERT model. So it's a lot of neural networks looking forward and looking backwards and looking between each other and giving a positional encoding to all words. Once that the BERT model has gone through the whole website, through the whole corpus of websites and has disambiguated between the different words, then those embeddings of words that have been disambiguated, for instance, in that case that we were talking about before, well, such where the water is, and well, such as well, it's okay, are put back into my list of seed words as two different embeddings. And at that point, I can assign them to each document differently and make sure that my prediction is more accurate. This is not smart stuff that came out of my brain. It's a methodology from someone else. I wish it came out of my brain, but I'm too busy cleaning data.
So this is more of a, I guess, a comment on that, but like you sounds like you're doing a huge amount of manual work cleaning this data, to which the paradigm of active learning might be a way to make that less painful, right? So trying to get the computer to tell you which things you should bother spending your time on. I wonder whether that's tried in this space.
It's a thing that I've been thinking about, is just that website texts are so heterogeneous. So it could be that from a website, you can just scrape something like access denied, access denied, access denied. And from another website, you get out like a book of poems, and that's the main problem. So a lot of times you really have to have a manual look at what you're getting out, and a lot of times trash is going to remain in the model. So there is a lot of trash that is going to be hidden and that you're not going to be able to clean out for as much time as you spend in it. I'm now on the 3rd year of the PhD, and I've had my data set for like 2 years now, and I still find trash. It's about writing function every time that you find some trash to say, oh, there is some trash. This is a function that I can use to get it out for the next time, and so on and so forth.
Aren't there components that are slightly more standardized, like the tricks that people do to get search optimization? to put them high in the rankings. I believe that they would induce certain types of more structured data, but I guess you can't rely on everyone doing it.
Yeah, page rank, right? Yeah, I've thought about it, but I didn't really go like very much on depth in that, I have to be honest.
Great. Well, thanks. I've used up too much time. Thanks.
I've got one more question. If we've still got, I'm just looking at my, I think we've got 2 minutes. Emmanouil, I was really, all the time I was listening to you talk, I was thinking about how one could visualize these connections and relationships. And you showed one slide, I think, of maps with lines on from different centers. And I just wondered if that is something that you focused on, or you and your group are focused on, kind of novel methodologies for visualizing these very complex spatial connections?
Well, we did something very simple here, and I probably didn't spend much time explaining it. We just aggregate the data at the regional level, and we had to do that because the trade data is only available at the regional level. Yeah. So we start by this high level of aggregation, and this is what how we model the data, and then we went to a lower level below, which is the local authorities. And we applied the trade model at the local authorities, for which we have no trade data and never had any. And I included some static visualizations as examples on the presentation. We are working on doing something more interactive to accompany the paper, which can hopefully be more useful to local authorities in order to see their own dependencies.
That's what I was thinking. It's around you kind of maximizing the impact of this work for decision makers, yeah, wherever they are.
So really this is why we're doing this visualization too, as an online appendix to the paper, which is currently in revising something.
Yeah, yeah.
One of the things is that it is multidimensional, which most human beings, myself included, have difficulty in visualizing. That's one of the reasons why I see you were using random forests, where you can sometimes take the individual decision trees, which go to make up the random forest, extract those, and people can understand that part of what is going on by looking at the individual decision tree. Finish comment.
Yes, thank you. We try to stay. I understand your point. We try to stay away from, the understanding the decision type of question, and we wanted to focus more on the actual prediction here, because just to follow up with what Kate was saying, this might be useful as a tool, for local authorities to understand their own trade dependencies as a prediction type of mechanism.
Really interesting. I think we've come to the end of the questions and our time. So it just remains for me to thank you so much, Emmanouil, and your colleagues that contributed to the paper, and to Giulia. Lovely to see your work, Giulia, coming to fruition. Really, really wonderful stuff. And yeah, you're part of the wider JGI family, so really great to see you presenting. And thanks to everybody who's joined us at lunch today. Tomorrow, when's our next one?
So the next one we have is Siddharth Jaggi on the 29th of March. So the Eventbrite, and the event will be posted soon. Marvellous. So I look forward to seeing as many of you there as possible. Have a great rest of your day. Bye then.
Thank you for having us. Bye, everybody.
Bye.